Welcome to solverfy.
So now we'll work on problem 76 from chapter 17. In this problem, we're told that a 1 molar sodium sulfate solution is slowly added to 10 milliliters of a solution that is 0.2 molars in calcium 2 plus and 0.3 molar in silver plus. And we're asked which compound will precipitate first, and whether it's calcium sulfate or silver sulfate, and how much sodium sulfate is necessary to initiate the precipitation. So we're given the KSP values for calcium sulfate and for silver sulfate. For calcium sulfate, it's 2.4 times 10 to the minus 5. And for silver sulfate, the KSP is equal to 1.5 times 10 to the minus 5. So here it's not immediately apparent based on the KSP values which one will start precipitating. Firstly, because they're so close in value, and second, because we have a 1:2 ratio for silver sulfate and a 1:1 ratio for calcium sulfate. So what we need to do is calculate when Q equals KSP for each of the compounds to calculate the amount of sulfate that's needed. So for calcium sulfate, it's 2.4 times 10 to the minus 5. And the concentration of calcium, we're told, is 0.2. This is another complicating factor because the concentrations of the initial cations are not the same. So from this, we get a concentration of SO4 minus as being equal to 1.2 times 10 to the minus 4. We can do the same thing for silver. And the KSP for silver sulfate is 1.5 times 10 to the minus 5. And then the concentration of silver is 0.30, but we need to square it because of the ratio here. And then this will still be multiplied by the concentration of sulfate, which if we solve for, we get a value of 1.67 times 10 to the minus 4. So the first, part A in this problem, we're asked which compound will precipitate first, calcium sulfate or silver sulfate. So from these values for sulfate concentration, we can see that the lower sulfate concentration is necessary for calcium sulfate to precipitate. So CaSO4 will precipitate first. And the second part of this problem is how much sodium sulfate solution must be added to initiate the precipitation. So we know that we need this 1.2 times 10 to the minus 4 concentration. So we can multiply this by the volume of our solution to get the amount of moles necessary, which is 1.2 times 10 to the minus 6. Then we can divide this by the concentration of the sodium sulfate, which we're told is 1 mole per liter, to get a value of 1.2 times 10 to the minus 6 liters, or 1.2 microliters, is the concentration necessary to start this precipitation.